Good afternoon, viewers at home. Welcome to Mathematics Lab with Mr. Major. We are looking at properties of angles and we are on part 4. If you are just coming across my video on properties of angles, then please do well to check my channel for part 1, part 2, and part 3 of properties of angles. In part 1 and part 2, I explained 6 different theorems on properties of angles. In part 3, I will look at some examples on the first 2 properties. And in this video, part 4, I'll be looking at examples on the remaining 4 properties that we have already discussed in part 1 and part 2. So please, you can check the channel for those videos. Now, in this particular question on the board, we are asked to solve for x. One thing we must know is that we have 4 different lines. This is one line. This is another line. This is another line. And this is another line. They are all meeting at a point. So that comes to our mind. Theorem number 3, angles meeting at a point. And the theorem on angles meeting at a point states that their sum is 360 degrees. That means when I add all these 4 angles together, the answer is going to be 360 degrees. So let me start from here. You can start from anywhere, please. You can start from anywhere. I choose to start from x. So we have x plus 152 degrees plus 51 degrees plus. Now, we know when we have this sign here, a box like this, it means a right angle. So if this is a right angle, that means the angle here is 90 degrees. So plus 90 degrees equal to 360 degrees. And what is the reason? The reason is angles at a point. Angles at a point, or angles meeting at a point. So let's add this together. 152 plus 51 will give us 203. Now, 203 plus 90 will give us 293. That means we have x plus 293 degrees equal to 360 degrees. If we collect our like terms, we have x equal to 360 degrees. 293 coming this way becomes minus 293 degrees. And 293 subtracted from 360 will give us 67. That means our x is equal to 67 degrees. So this is the answer to x, 67 degrees. Just know which of the theorem can be applied for a particular question, and then you will get your answer correctly. Let's try another example. Okay. Now let's look at example 5 now. In example 5, we have 8 different angles, and only one of them is known. And that is this angle that is known as 70 degrees. Every other angle is lettered, and we are to look for the lettered angles. Now, without waste of time, let me just start solving. The easiest angle we can look for here is angle y. If you look at this angle, this is a straight line and this is another straight line. And when 2 straight lines cross each other, the opposite angles are vertically opposite. That means y is vertically opposite to 70. And we know vertically opposite angles are equal. That means angle y is equal to 70 degrees. And the reason is vertically opposite angles. Now, we've gotten y. We can look for angle x here because, like I said, this is a straight line. And since it is a straight line, it means these 2 angles are meeting on this line, these 2 angles. So that means 70 plus x is 180 degrees. So we have here x plus 70 degrees equal to 180 degrees. Reason is angles on a straight line. Now, That means our x here is equal to 180 degree plus 70 coming this way is minus 70 degree. 180 minus 70 will give us 110. That means angle x is equal to 110 degrees. Now we've gotten angle x. We can look for angle z here. Here, angle x and z are also vertically opposite, since these two straight lines are crossing each other. That means angle z is equal to angle x, and the reason is vertically opposite angles. And we have known angle x to be 110. So since z is equal to s, it then means that our z is also 110 degrees. Now we've gotten angle z. We are left with MN, P, and Q. Let me take those ones here. Now for angle M, I'm going to, let's note, this line and this line are parallel lines, as these arrows are indicating. They are parallel lines. And that means this line is a transversal to the parallel lines. Now, angle 70 here is occupying the top left-hand side. Angle M is also occupying the top left-hand side of the second parallel line. So since they are occupying the same position, that means they are corresponding angles. So we say angle M is equal to 70 degrees. And the reason is corresponding angles. Corresponding angles. Now, that means we are done with angle M. I want to move to angle N. For angle N, the angle N is equal to angle X. Why are they equal? Because angle X is occupying the top right-hand side. Angle S is occupying the top right-hand side of the first parallel line. And angle N is also occupying the top right-hand side of the second parallel line. That means angle N is equal to angle X. And the reason is the same reason, corresponding angles. And since corresponding angles are equal, it means that our N is equal to S. We found S to be 110, so angle N is also 110 degrees. So we are done with angle N. For angle P, we can still use corresponding angles if we want. We can use vertically opposite angles if we want, because M and P are vertically opposite here, because this straight line and this straight line cross each other. So we can easily say P is equal to M, and the reason is vertically opposite angles, meaning angle P is equal to, we've got to M to be 70, so angle P is also 70 degrees. And then for angle Q, Q is vertically opposite to N. So we say angle Q is equal to N, and the reason is vertically opposite angles. And N, we have obtained N to be 110. So therefore, Q is equally 110 degrees. With this, we have solved for all the angles. We have solved for all the angles. Now, there are several angles there that we can use other theorems that we have looked at to solve. Take, for instance, we can solve for angle N here, though we have solved for it using vertically opposite angles. We can also, we solve for it using corresponding angles. This is where we solve for it. We can still solve for the same N by saying that N is equal to Z. Remember, I talked about alternate angles, and I said alternate angles, they are interior and at opposite side of the transversal. So this one is at the left hand top, and this one is at the bottom, bottom right hand. So they are occupying opposite direction. So Z is also equal to N, or N equal to Z, and the reason will be alternate angles. Now we already know Z here to be 110, giving us N to be 110. The same answer we obtained here. We can use the same thing to solve for angle M by saying M is alternate to Y. So we say M equal to Y, and then since Y is 70, M will not be equal to 70 as well. And that is the same answer we got when we use corresponding angle to solve for M. Now, we can also use interior angles of a transversal to solve for the same N by saying that y plus N. Remember we said for interior angles of a transversal, they are supplementary if they are occupying the same side of the transversal. Here, these two are occupying the right-hand side of the transversal. So y plus N will be 180. And since we already know y to be 70, that means our N will now be 180 minus 70. And that is equal to 110 degrees. The same answer we obtained here. We can also use that to solve for M, interior opposite angles of a transversal. At the left-hand side this time around, it are supplementary. So Z plus M is equal to 180. And since we already know Z to be 110, that means our M will now be 180 minus 110. And that will give us 70. The same answer we got here. So we can just play around these theorems and we will be arriving at the same answer, provided you are using the correct theorem. But 2 people or 3 people can use different theorems, provided their theorems are correct based on the diagram or figure given, they will arrive at the same answer. Okay, please, in the next video, properties of angles, part 5, I will be looking at other examples that are a bit more complex than these ones. Just play around them, watch part 5 of these properties of angles, and you will enjoy them. Please, if you've not subscribed to my channel, please subscribe and share my videos, like and comment. Thank you.